So this is the 9-1 memory quiz practice. So you can find it in Google Classroom. Just bring it over into Notability. We're going to do it together today, and then please submit it along as soon as you're done to get yourself some points. Now, on the memory quiz next week, you're going to need to know the things that you see here. So there are 11 items. The first 3 things you're going to need to know are the Pythagorean identities. The first one is that sine squared plus cosine squared is equal to 1. And then 1 plus the tangent squared equals the secant squared. And then the cotangent squared plus 1 equals the cosecant squared. So those are the 3 identities that you need to know by heart, so that you can, get the points for those. The way that you can get some bonus points is by rearranging those formulas. So let me show you kind of some bonus point opportunities for those 3. If we take the first equation and we subtract a cosine squared to the other side, we get that sine squared is equal to 1 minus cosine squared. So that could get you a bonus point. But if we take the first equation and instead of subtracting a cosine squared to the other side, if we subtract off the sine squared, we get that cosine squared is 1 minus sine squared. So you could get yourself some bonus points by knowing those 2 alternatives to the first equation. So the first equation can be rewritten actually 2 more times. Now if we do the same type of technique for number 2, if we subtract the 1 from both sides, we get the tangent squared is secant squared minus 1. Or we could actually subtract the tangent squared, and we could get that 1 equals secant squared minus tangent squared. A trick that they like to use sometimes when we're verifying identities is sometimes if a 1 is sitting in the problem and the other pieces have sines and cosines, you can replace it with the sine squared plus cosine squared. If your problem has secants and tangents and a 1 is sitting there, you can actually replace it with secant squared minus tangent squared. And then we get 2 from this one. So let's subtract the 1 from both sides. That gives us that cotangent squared equals cosecant squared minus 1. Or we could subtract the cotangent squared from both sides, and we get 1 equals cosecant squared minus cotangent squared. So these are not ones you have to have memorized, but you can get some bonus points. I'm going to have you write them on the back of the quiz next week. Sine squared plus cosine squared equals 1 gives you those 2, just by rearranging. 1 plus tangent squared equals secant squared gives you these 2. And then cotangent squared plus 1 equals cosecant squared gives you these 2. So these you have to have memorized. These are kind of just some bonus points you can get by rearranging the originals. Next, let's take a look at the even and odd identities. Sine and tangent are both odd. These ones are odd. This is the only one that's even. Now what does that mean? Well, odd is the fact that it has origin symmetry. Even is the fact it has y-axis symmetry. So if we were actually to look at the pictures, we would see that. So because 1 and 3 are odd, the negative can come out and multiply in front of the trig function. So that's what happens for 1 and 3. Sine and tangent are odd, so a negative inside can be removed and put on the outside. Since cosine is even, what a negative on the inside does technically is flip across to the y-axis. If it has y-axis symmetry, there won't be any change. So the negative on the inside is the same as the original function. So you'll notice there is no negative on that one. What are some bonus points you can get for this one? Well, if you know the even and odd, how those work for the reciprocals, the reciprocal of a sine is a cosecant. The reciprocal of a tangent is a cotangent. So if the original is odd, the reciprocal is odd. The reciprocal of the cosine is the only reciprocal that is actually even as well. So the secant of negative theta is the same as the secant of theta. So these ones are even. So the negative would disappear. These ones are odd. So the negative goes on the outside. So there's a little bit of bonus you could get by telling me, you can tell me the even and odd, and you can tell me the reciprocals. Speaking of reciprocals, the next three things that you need to know on the quiz are our reciprocal functions. The reciprocal of the sine is the cosecant, so sine is 1 over the cosecant. Cosine is secant, so that's 1 over the secant. And the reciprocal of the tangent is the cotangent, so that's 1 over the cotangent. You can get some bonus here by doing one little rewrite for me. For the first one, you could also say that the sine times the cosecant equals 1. For number 2, you could say that the cosine times the secant equals 1. And for number 3, you could say that the tangent times the cotangent equals 1. Okay. So our reciprocal functions, you need to know definitely these three. But if you tell me what the multiplication does each time, that will also get you some bonus points. So there's lots of bonus you can get on this quiz. And the last thing that you have to know on the quiz next week is the quotient identities. The tangent and the cotangent are made up of two things that are fractional. One we tend to know real quickly. The tangent is sine over cosine. And the bottom one there, cotangent, is the reciprocal of that, so it's cosine over sine. And yes, there is some possible bonus you could get. And the bonus just comes from the fact that if we cross multiply, we get kind of a new looking fact. The first one is that tangent times cosine equals sine. So if we cross over that cosine on the bottom, we get the tangent times the cosine is always equal to a sine. A similar idea happens for the second one, that the cotangent times the sine is equal to cosine. So you need to study this. You need to know the facts that are in blue by heart. The facts that are in red are some opportunities to get yourself some bonus points on the quiz. Please, at this time, submit this into Google Classroom so you don't forget and get yourself some points. Okay? So that's the first thing we're going to do today. So submit this into Google Classroom, get yourself some points. Now all of these facts, again, once you've finished what you see here, you might want to do that little screenshot, because that can help you. Now those aren't all the facts. I will be putting a little sheet with all of the formulas and facts on it in Google Classroom you'll be able to look at. But this is the main one so far that we have to have memorized. Now please, at this time, submit it into Google Classroom. Once you're in Google Classroom, please open up the 9-1 practice worksheet. 9-1 practice worksheet, which has the 8 problems that you see here. So now at this time, open up the 9-1 practice worksheet that you see here, the 8 problems. There are 8 problems. Now, because these take time, there's only 8 of them. Yesterday's assignment I cut down, there's only, I think, 10 problems in the assignment for that. But what we're going to do right now is we're going to do the odd ones together. So then you'll only have 4 more that you're responsible to turn in by Saturday. Okay, so at this time, let's do all of the odds together, 1, 3, 5, and 7. Let's start with problem number 1. These problems are prove each identity. Now remember, to prove each identity, we can use those facts that we saw on the practice. Some of the other facts we learned in the second part of the lesson. So those facts are going to help us. And what we're going to do is we are going to hold one side and we're going to manipulate the other side. Okay? So it doesn't show it very well. This is an equal bar. It kind of got cut off there. I think the easiest thing to hold is the right side, but I want to make a little note in my brain or on the paper. Although I can't manipulate the right side, I know from the facts we just talked about that 1 over the secant is a cosine. So that right side is technically equal to a cosine. So if I can make this become a cosine, I got it. Okay? Okay. So I am going to hold this side. This is my answer. I looked in the back of the book. The answer said 1 over the secant. So since that other side is equal to a cosine, if we have lots of trig functions mixed together, my hint to you was always make them what they are in relationship to sines and cosines. So we're going to make secant 1 over the cosine. We're going to make tangent sine over cosine. And since that sign there is actually not fractional, you can put it over 1 so it looks like a fraction. Now let's think algebraically. This is one thing. So you need to think, how can I make this one thing? Well, if I see 2 fractions that I want to make one thing, I have to have a common denominator. I actually have a common denominator. This one is 1 over cosine. This one is sine squared over cosine. So since they are both fractions with a cosine in the denominator, I can add or subtract the tops. So I get 1 minus sine squared over the cosine. And guess what? Now if you see ones and squares, you need to think Pythagorean. Remember I told you in the bonus section of the Pythagorean that if you rearrange 1 minus cosine squared, another little note I can make up here, 1 minus sine squared is the same as cosine squared. So I can take this out and make it a cosine squared. Cosine squared over cosine squared, or cosine squared over cosine, leaves me just a cosine. And isn't that the answer I wanted to look for? But did they write it like that? No, they did not. They wrote cosine as 1 over the secant, so we can write cosine as 1 over the secant because we know those things are equivalent. So we never touched the right side. We used some facts to help us. We were able to manipulate that left side. And what happened? We rewrote it in sines and cosines using substitution. We combined our fractions. We used a Pythagorean. We did a little bit of algebra. We could use one more fact. So there is problem number 1. Now, let's look at problem number 3. Number 3, I see a fraction equals something a little simpler. So I'm going to hold this as my answer, and that means that I should be able to manipulate that to turn into a sine squared. Well, I see lots of trig functions, and like I've mentioned before, if I see lots of trig functions, the first thing I want to do is change them into their sine cosine equivalent. So since secant is 1 over the cosine, technically right there I have a 1 over the cosine times a sine. And just to save room, that means that the sine would go on top and a cosine would go on the bottom. Now, we know that tangent and cotangent can be written as sines and cosines because of our quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. Now, a trick that I remind my calculus students a lot, fractions tend to come up a nice amount in calculus, is that if I see a fraction contained within a fraction, I can't have that. So I'm going to use a little trick. Whatever the denominators are, I see a cosine and I see a sine. Because fractional equivalence, a fraction won't change if I multiply the same thing on top and bottom. So I can multiply the top by the cosine I need in green and the sine I need in yellow. And I have to just do the same here. I can multiply by a cosine and a sine. So what I'm going to do is I'm going to multiply all the tops by cosine sine, and some things will reduce down. If I multiply, because this is a whole thing, it goes on the top. Sine times cosine sine over a cosine. The cosine cancels, and I'm left with 2 sines. So I'm left with a sine squared. That's a good thing. That's what I wanted to be left with. That's my answer. That's great. Okay, now let's do this. I'm going to multiply this on top right here. Now let's think about when it goes on top right there. The cosine on the bottom and the cosine here are going to cancel. What's left? A sine squared. Let's do the same thing here. When I multiply this on the top here, the sines cancel. I'm left with a cosine times a cosine, which is a cosine squared. Now, I see squares and sines and cosines. I think Pythagorean. Sine squared plus cosine squared is equal to 1. That is a fact that I'm allowed to use at any time. So this is the same as 1. So it's already clear how I get the correct answer. Sine squared divided by 1 is sine squared. That's what our answer was. So remember, in identity, the answer is right there. It is your job to do the algebra to prove that the answer is right there. And you can pick any side to mess with. Usually I try to find the one that I think looks a little simpler, and I hold that. Now, if that isn't working for you, you can erase it and hold the other side and try the other side. So there's lots of ways to do that. So there's example 3. Or problem 3. Let's do problem number 5. both sides are similar. They both have subtraction. They both have some squares in them. So I think this one's a little simpler just because it only has a sine and not a cosine in it. So let's hold that one. So you need to think to yourself, okay, what do I know has squares in it and cosines and sines in it? Well, the fact I know is that sine squared plus cosine squared is equal to 1. So the only one I don't really want to be there, I don't want this here because there's no cosine on this side. But if you do a little rearrange, that's why those bonuses were so important. If I do a cosine squared, that's 1 minus sine squared. So that is something I'm allowed to substitute in at any time. This is the same as 1 minus sine squared. Oh, I'm sorry, those are y's. Let's make them y. Well, gosh, look at our answer and look what we just now have. These are like terms. I can add them up. -1 and -1 makes the -2. I found my answer. 1 minus 2 sine squared. I'm done. It'd be nice if they all were that way. They're not all that way. But that's a good one. So that is number 5. Now we're going to do one more together. And then it is your job by Saturday to finish up the even ones. So you have 4 more to try. Let's take a look at number 7. For problem number 7, I always kind of tend to think I have more to work with in that fraction side than I do the other side. One thing I would think about is that cosecant squared is the same as 1 over sine squared. I don't know if that's going to help me, but it's a fact. So when I hold that side, I have to keep this fact in mind that I might get 1 over sine squared, but I can immediately switch that into a cosecant squared. So if I see another way to write this that's a quick substitution, I think, oh, well, that might be what the answer looks like, and then I just got to switch it to get my final answer. Okay, so those are just a little fact we can use. I see squares over here containing a secant. So let's take that and let's deal with what we know. The Pythagorean that contains a secant is that 1 plus tangent squared equals secant squared. Okay. So since this is one piece, taking out this secant squared and making it 1 plus tangent squared probably isn't very helpful. You could try it. It's not going to probably help you too much. But this is the one I'm really concerned about. Can I make that one thing? Well, if I do a little rearrange, remember how I showed you the rearranges. If I subtract 1 from both sides, I get that tangent squared is secant squared minus 1. So I know I can replace this perfectly with a tangent squared. Secant squared minus 1 is exactly the same as a tangent squared. So I get secant squared over tangent squared. Now I've already eliminated the addition and subtraction from the left side, so I'm getting closer to being one particular thing. The one particular thing is a cosecant, which is directly related to a sine. So let's do the trick I've said multiple times. If you're unclear and you have multiple trig functions, make them sines and cosines. Secant squared is 1 over the cosine. Tangent squared is sine over cosine, so it would be sine squared over cosine. Well, we found a sine sitting there, and we found some other good things that are happening. If we do big C over little c, remember big C multiplies to go on top, little c multiplies to go on the bottom. So let's do that multiplication. Big C multiplies to go on the top. Little c multiplies to go on the bottom. Or you could have seen right off the bat that the cosines are in such a location that they're going to cancel. And if they cancel, that leaves us with 1 over sine squared, which is what I told you to look for, because what is 1 over sine squared the same as? It's the same as our answer, cosecant squared. So there you go. There is problem number 7. So remember the technique. You try to find something that is equivalent to. You stick it in. You try to see some algebra, always keeping in mind the answer that you're looking for. So a cosecant squared is the same as 1 over sine squared. If I can get it to be 1 over sine squared, I'm golden. I got the answer. So there is number 7. Remember, you get to pick which side you want to try to manipulate and leave that side alone. You can only touch the one side. It's not a traditional equation. It's a verification. So you're trying to manipulate one side into the other side without touching the other side. So you have 4 more to go. Let's just take a minute and look at some strategies for these. For number 2, I would probably hold this side. I would probably split, see how it's 2 unique pieces. I would probably put both these over sine so that you could see what happens. For number 4, I would probably make these sines and cosines since they're all so different. Then look what your fractions are, and you might need to get, what is it called, common denominators. Maybe not, but you need to mess with that. Make them sines and cosines for number 4, hold the 1. For number 6, I would probably look at what these are with sines and cosines. There's squares and ones there. There's probably a Pythagorean that's going to happen. Number 8, both sides are similar as far as which one to hold. If you do this one, you have to turn one of them into a Pythagorean. I would probably mess with this one, I would probably mess with this one, making these sines and cosines. That might be your best bet. Okay, so again, this assignment is not due till Saturday. You'll have 4 more left. So far you have your 9-1 homework, which were those 10 problems, and this 9-1 practice is due Saturday. The 9-1 memory quiz practice we did at the beginning, put that right in Google Classroom. You have the rest of the class period. I want you to work on either this or your 9-1 homework so that you get practice while it's fresh in your brain. Okay, so there you go.